In this video, we're going to look at what we call trigonometric equations with expanded domain. And hopefully it becomes clear eventually what we mean by expanded domain. So what we're talking about is ones that have something like this, where we've got, so it's sine of 2 theta, yeah? Not just sine of theta is equal to a half. So anything where you've got n times your variable, so some number times your variable. Now, with these, it's kind of a common thing that we do in maths. We take a problem that we don't know how to do, these ones with the coefficient to our variable, and we turn them into something we do know how to do, so a problem without one of those. And let me just show you how that works. So what I can do is, I don't know how to solve this problem, right? Sine of 2 theta is equal to a half, but I would know how to do it if it was, say, this. Sine of A is equal to a half. I already know how to solve that. So that's what we want. What we're going to have to do, though, is in order to get that to happen, is we also need to change our domain so that we know where we're looking. So this is where the name comes from, expanded domain, right? Because when we do this change, we often have to expand our domain, sometimes even shrink it as well, but as in we have to change our domain for it to work. Let me show you how that works. So if I want to do the substitution that A is equal to 2 theta, well then I would get this, right? Sine of A is equal to a half. For my domain though, if I times the whole thing, so 2 times the whole thing of 0 is less than theta is less than 2 pi, what do I get? Well, 2 times 0 is still 0. Less than or equal to, well, theta times 2 is 2 theta, and 2 pi times 2 is 4 pi. So now I can do my substitution. I've got 2 theta here, so I can just replace 2 theta in my domain by A. And so I'm solving the problem. Sine of A is equal to a half for 0 is less than or equal to A is less than or equal to 4 pi. Now we actually did this example very recently, as in something really similar to it, but you need what? That is root 3. Well, it's a bit of a manky looking 3, but that's okay. 1, 2, and then what we get, we're doing radians here, so we got pi on 3, and this one is pi on 6. So, sine of pi on 6, opposite over hypotenuse, is going to give me a half. So in the domain of, let's just get rid of that, of 0 to 4 pi, so A could be, if you think about it, let's just quickly change color. So one of the values between 0 and 4 pi is pi on 6. So what, that'd be about there. That'd be okay. Another one, well, we've got our CAST. So also here, right? Round to, well, not quite that, but so where we've got that, so we could have pi on 6. We could also have round to pi on 6 less than halfway, which is pi, so what it'd be 5 pi on 6 if you take away the 1 pi on 6 from pi. But we're not done. So we're now looking in our expanded domain from 0 to 4 pi. So there are more things that fit the bill. If we go all the way around and then to here, that would be allowed as well. So that'd be 2 pi plus pi on 6. So what? 2 pi in terms of pi on 6 would be 12 pi, so we're talking 13 pi on 6. And then we're also allowed to have all the way around there and to back to kind of what our second solution was, an equivalent one to that. So what? That'd be, so 3 pi in terms of pi on 6 is 18 pi on 6, and we're taking away 1, so 17 pi on 6. And those are our values for A, so we've done a lot of work. We've got most of the way there. The thing is, the question is not asking you to find A. It's asking you to solve this equation that is in terms of theta. So we need to go back to theta. So we need to redo this substitution. So A is in fact 2 theta. So 2 theta is equal to pi on 6, 5 pi on 6, 13 pi on 6, and 17 pi on 6. So then, if we want theta by itself, we got to divide both sides by a half. So this, when we divide by a half, is theta. This, when we divide by a half, Well, what do we get? Let's just do it down here. So pi on 6, sorry, divided by 2. My apologies. When you divide by 2, that is divide by 2. So that is pi on 6 times by 1 on 2. So it's going to be pi on 12. And this one, you can work out for yourself if you don't believe me, but it's going to be 5 pi on 12. This one's going to be 13 pi on 12. And this is going to be 17 pi on 12. One thing that is kind of interesting that you might notice is if you think about it, 17 pi on 12 is within this domain of 0 to 2 pi, whereas 17 pi on 6 is not. So your values for theta should fit within the original domain, even if when you're working it out using this expanded domain, some of them won't. So those are the 4 values that solve this equation. And let's leave it there.